Identify a Hamilton path and, I should say and or, a Hamilton circuit for a given graph. So let's remember that a Hamiltonian circuit is a circuit that visits every vertex once with no repeats, but because it's a circuit, it starts and ends at the same vertex. A Hamiltonian path is a path that visits every vertex once with no repeats, but does not have to start and end at the same vertex. Okay, so what is one Hamiltonian circuit from the graph below? Now, the key here is that we have to start and end at the same place. So if we were just looking for paths, we could have a gajillion of them. Well, not a gajillion, but a lot. So we're looking at, okay, I'm going to start here at A. That means I need to end at vertex A. So let's go from A to B, B to K, K to L, L to C, C to D, D to E, E to F, F to G, G to H, H to I to J, and J back to A. That allows me to touch every vertex and end up back at the end. So that is one Hamiltonian circuit from the graph given below. So when you're doing this, it might help to have colors that you can draw on things. I'm a visual learner, so actually drawing on top of things really helps for me. And does a Hamiltonian path or circuit exist on the graph below? Well, you probably noticed pretty quickly that over here, A only has a degree of 1, which means if I would start at B and go to A, there's no way to get back to B without repeating a vertex, which is against the rule. So we cannot have a circuit, right? Because there's no way to start and end at the same spot. Because I can't get to A two different ways. So we know we can't have a circuit, but we could still have a path. So if I start at A, let me get a bigger one here. If I start at A and go to B, I could go from B to F, F to C, C to D, and D to E. So I would start at A, I would end at E. I touched every vertex without repeating, and thus a Hamiltonian path for this particular graph. And that's just one of a few.